a shot.
No. 3. There's another one. That was a stop.
Nationally, 53.5 of drivers stop at stop signs. Our question is, do drivers around Granada stop at stop signs more? We want to test a claim about the true proportion of Granada drivers who stop at stop signs. We will use a 1 proportion z-test. Our null hypothesis is that p is equal to 0.535 or 53.5%. Alternative hypothesis is that Granada drivers stop at stop signs more, so its p is greater than 0.535 or 53.5%. Our significance level is 5%. Okay, so for conditions, the data is convenience because we did 3 stop signs closest to Granada and observed the first 15 drivers at times convenient for us, but we must assume SRS and proceed with caution. NP equals 144.45, which is greater than 10, and N times 1 minus P equals 125.55, which is greater than 10, so we can assume approximate normality. And 3, there are more than 900 drivers around Granada, so we can assume independence.
Calculation.
So for our calculations, we plugged our values into the equation for a 1 proportion z-test and got a p-value of 0.9999.
This is our data, and for the weekdays we went to all 3 different stops at 3 different times, and as you can see, they were rarely over the national average. And the same for the weekend. We went to 3 different stop signs around Granada at 3 different times, and most of them were very few number of cars in proportion that stopped.
Our p-value, 0.9999, is greater than our significance level, 0.05. We failed to reject our null. We do not have enough evidence to prove Granada drivers stop at stop signs more than the national average. Our normal distribution curve shows that the national average is at 0.535 and our mean is at 0.389, which is way below the national average.
Our biggest obstacle is making an SRS. It was a convenience because we took the first 15 cars at times, days, and locations convenient for us.
Our normal distribution curve shows that our mean is at 0.35. What? 535, not 35. Whatever, okay. Our distribution... This should not be as hard as it is, okay? Take 237.
This is our data for